Factoring quadratic trinomials with a leading coefficient of 1. So similar to that last lesson where we started off with some distributing to kind of review, we're going to do the same thing here. And again, because this idea of factoring, which is a total new term to you most likely, is just the reverse of distributing. So let's practice distributing. So it says recall multiplying binomials by distributing from the beginning of the year. So let's distribute here. So remember, we're multiplying everything in this parentheses times the times the quantities in the other parentheses. So x times x gives us, let me zoom in here, x times x gives us x to the second. X times 3 would be 3x. Now I'm going to distribute 7 to everything. 7 times x is 7x. And then 7 times 3 is 21. Combine your like terms. That would be x to the second plus 3 plus 7 is 10. So 10x plus 21. So that was distributing. Let me do more. I'm going to go somewhat quick here. X times x, x to the second. X times 1 is just 1x. 6 times x, 6x. 6 times 1 is 6. X plus 6x would be 7x. Let me do a couple more. X times x is x to the second. X times 5 is 5x. Negative 8 times x, negative 8x. Negative 8 times 5, negative 40. Combine our like terms. 5x and a minus 8x would be negative 3x. And then one more here. X times x would be x to the second. Negative 3 times x would be negative 3x. Negative 4 times x would be negative 4x. Negative 4 times negative 3 is positive 12. Combine your like terms. Negative 3x and a negative 4x would make negative 7x. Okay. So the reason that I wanted to review this distributing property is because factoring is the opposite. But there's a little bit of a pattern that you really need to understand and see with these 4 examples that I just did. So let me erase some of these arrows here just to not muddy this up. So like I said, factoring is the opposite of distributing. So what we're going to be doing for the rest of this lesson is we're not going to take these 2 binomials, multiply them and get an expression. We're going to take this expression and we're going to turn it back into those 2 binomials. So what we're going to do, like on A, we're going to take this expression here and we're going to turn it back in to this factored expression where we have 2 binomials multiplied by each other. And in order to do that, we kind of need to see this pattern that's happening with each of these. So if we compare the final answer to the original problem, we should see some things. So let me kind of just cross this out right here because I don't want to really even look at that middle step. If we compare on A, the final answer to the original problem, and we're trying to reverse it, what you should be seeing is that this 7 and this 3 relates to the answer down there at the bottom. 7 times 3, we're doing this distributing, we're always doing that 7 times 3, which is going to give us this 21. So we see the relationship there. Those 2 numbers in the parentheses with that x multiply to this third term here, this 21 that I've highlighted. And those 2 numbers, that 7 and 3, you'll notice add to this 10. 7 plus 3 is 10. So those 2 numbers within those parentheses, they multiply to that last number, yet they add to that middle term. And look, you're going to see that with B as well. Again, let me just cross that out so we're not looking at that. I want you to look at that. 6 times 1 is 6, and 6 plus 1 is 7. Look at C. We see that relationship again. Negative 8 times 5 is negative 40. And negative 8 plus 5 is negative 3. Look at that relationship. Those two numbers in there kind of determine what our distributed expression looks like. Just one more. Negative 4 times negative 3 is positive 12. And even negative 4 plus negative 3 is negative 7. So that's the relationship here that you should be seeing. So this is going to be very important as we try to reverse this distributing and try to factor, okay? So let's jump into it. It says factoring is the opposite of distributing. Again, it's got that tip there to check your answer, distribute your answer to see if it matches the original problem. Never forget that, okay? So the property that we saw above there, so I'm going to kind of set up this template here because we're trying to factor it into what we saw. So we're going to need an x times an x to give us an x to the second. The property that we saw is that the two numbers in there, they need to multiply to this last number, yet add to this. So the question is, and you're going to have to use your brain here, what numbers multiply to 8 and add to 6? Think about it. What numbers multiply to 8 yet add to 6? That answer is 4 and 2. 4 times 2 is 8, and 4 plus 2 is 6. So I'll put those in there. And it's factored. That's it. That's the answer. And again, to check your work, you can distribute. So you don't need to write what I'm about to write here, but to check your work, x times x, x squared, x times 2, 2x, 4 times x, 4x, 4 times 2, 8. The 2x plus the 4x makes 6x. Boom. Look at that. That is the same as the original expression. That means I did it correctly. Erase that. Okay, hold on. All right. Same here. Then kind of set up my template here. X times x. I'm going to need an x times x to give me that x squared first term. Now what goes in there, those numbers need to multiply to the 24, yet add to 11. So you got to think, what numbers multiply to 24 and add to 11? So you got to think about it. It'll take you some time. It's not a race. Well, those numbers would be 8 and 3. 8 times 3 is 24. 8 plus 3 is 11. And again, you can distribute if you need to. I'm not going to show the distribution on this one. Maybe on a different one. Let me do E. Kind of set up my template here. Whoops. Again, the question now, here we got some negative in this one. Gives it a little more challenging. The question is, what numbers multiply to negative 14 and add to positive 5? So not many things multiply to 14, right? 1 and 14, 7 times 2. But it's got to be negative 14, so one of them has to be negative. So the things that multiply to negative 14 yet add to positive 5 could be positive 7 and a negative 2. Positive 7 times negative 2 is negative 14. Positive 7 plus negative 2 is 5. Again, we can distribute to check to see if this is correct. Let me do that. Again, you don't have to write this if you don't want to. But I distribute x to the second. I distribute negative 2x, distribute, 7x, distribute, negative 14, combine my like terms, negative 2 plus 7 is 5x. Look at that. That is the original expression, meaning I did it right. Let me do another one with a negative. I'm going to do g. Again, needs to multiply to negative 36. Let me set up my template here. Multiply to negative 36, yet add to positive 5. So 36 kind of has a lot of factors. 1 in 36, 2 in 18, 6 times 6, 4 times 9, 12 times 3. So there's a lot, but there's only one combination to where it's going to add to positive 5. So again, what numbers multiply to negative 36, add to positive 5? Take your time to think about it, but that's going to be a positive 9 and a negative 4. Positive 9 times negative 4 is negative 36. Positive 9 plus negative 4 is 5. And again, distribute if you feel like you need to. Let me roll on and do some more here. Numbers have to multiply to negative 22, yet add to negative 9. That would be negative 11 and positive 2. Negative 11 times 2 is negative 22. And negative 11 added to a positive 2 would be negative 9. Let me show you a couple more. Now this one's tricky because it's got to multiply to multiply to positive 36, yet add to negative 15. So if two numbers are going to multiply to a positive yet add to a negative, that should hint at me that both of these are going to be negative. Because it's got to multiply to a positive yet add to a negative. So they're both going to have to be negative. And it should be 12 and 3 there. Negative 12 times negative 3 would be positive 36. Negative 12 plus negative 3 would be negative 15. This one's similar because they need to multiply to a positive number, yet they're adding to a negative. So multiply to positive 40, add to negative 14. I know they're both going to be negative here. That would be 10 and 4. Let me show you one more. Now on this, remember, this is like a coefficient of 1 when it's not there. So this we're going to multiply to negative 30, yet add to negative 1. One of them is going to have to be positive, one's going to have to be negative, right? Because it multiplies to negative 30. So you think about it. What multiplies to 30? 2 and 15. That's not going to get me to a negative 1 when I add. 3 and 10. 3 times 10 is 30, right? But that's not going to get me to a negative 1. What about 5 times 6? If I do a negative 6 and a positive 5, negative 6 times 5 is negative 30. And negative 6 plus 5 is negative 1. So there are a bunch of examples. Now I'll let you try the rest. Now I didn't really show it on any of these on this page here, but remember, you can always distribute to check your answer. So you should, whenever you're unsure, you should distribute to check. So like right there, I just distributed and I did get the original expression. So that means I did it correctly. So always use that as a hint. So that's factoring when the leading coefficient is 1. And when I say leading coefficient of 1, that means it's just all 1x squareds, right? We're going to get to harder ones in the next lesson where the leading coefficient isn't 1, but that's factoring when the leading coefficient is 1.